Hello everyone and welcome to this presentation video for a course that I am teaching at the University of Bagi Mokhtar Anbar. The module is called Thermodynamics. First of all and before starting, allow me to introduce myself. I am Rawia Hendi, Doctor in Chemistry of Materials and Corrosion and currently Assistant Professor Class B, MCB, at the University of Bagi Mokhtar Anbar Faculty of Technology, Electronics Department. Here is my email address. You can contact me with any questions. This thermodynamics module, it is the fundamental module intended for students of electronics, first bachelor's degree in automatic EAD and automatic and computer science. Leaving the training of students will integrate the complementarity of different chemical training. Course objectives and interest. This component aims to introduce the student to thermodynamics, 3 principles of thermodynamics. To deepen knowledge of the first principle of thermodynamics, statement, the notion of internal energy of a system, application to the perfect gas, the enthalpy function, heat capacity, reversible transformations, isochoric, isobaric, isothermal, adiabatic, the second and third principles of thermodynamics. To examine the main mechanisms that govern the transformations of the state of a system. To present the industrial applications resulting from the mastery of microstructures. To acquire the scientific basis of the transformations of the state of a thermodynamic system. To interpret the physical and chemical properties. Prerequisites to be able to follow this course called thermodynamics. This educational subject deals with and provides the necessary foundations of classical thermodynamics for applications to combustion and thermal machines. It is important to have some basic knowledge and friable skills to succeed. Basic notions and tools in mathematics, physics, and chemistry. Problem-solving skills. This course is divided into 6 chapters. Chapter 1, a reminder of the general notions of thermodynamics. Chapter 2, the concepts of the first principle of thermodynamics. Chapter 3, applications of the first law of thermodynamics. Chapter 4, concepts on the second principle of thermodynamics. Chapter 5, concepts on the third principle of thermodynamics. Chapter 6, free energy and enthalpy, criteria for the evolution of a system. The figure is a concept map that shows in more detail the content of each chapter. The detailed course outline is available online. At the end of the semester, a test in the form of a written exam is carried out and counts for 75% of the final grade and 25% of continuous assessment. Let us now move on to the 5th, which deals with the third law of thermodynamics. Entropy is a measure of the degree of disorder in the system. An increase in entropy is thus interpreted as an increase in disorder. An increase in temperature T favoring disorder, S increases with T. Thus, the third law of thermodynamics states that the entropy of a pure crystallized substance is 0 at absolute zero temperature. S, T equals 0 K, equals 0 J, K. Absolute molar entropy. This third principle allows assigning an absolute entropy to any pure substance brought to temperature T. The absolute entropy of a pure compound A at temperature T is the variation of its entropy between 0 Kelvin and temperature T at constant pressure. According to the following equation. The absolute molar entropy (T) of a pure substance at any temperature T can thus be calculated by considering all entropy terms, from the initial state, T equals 0 K, S0 equals 0, up to the considered temperature. For example, let's consider the calculation of the entropy of a pure substance in the gaseous state. We will take into account the following transformations. According to the following diagram. The absolute entropy at temperature T is the sum of the various entropies. According to the following equation. S0 equals 0, absolute entropy at T equals 0 K. So we now give a simple example of how to calculate entropy. 2. Entropy of a chemical reaction. Let's consider the following reaction. AA plus BBCC plus DD. According to the Hess law. Some exercises for students to see how well they understand the lesson. The exercises are as follows. These are some references that the student can use to broaden his understanding of some mysterious questions. We are coming to the end of this video. Thank you for your attention and soon to the new video.